So for do now number 2, we want to know, is A on the angle bisector of angle XYZ? Okay, so angle XYZ is that angle there, and they want to know if A lies on the angle bisector. So basically they want to know, is YA the angle bisector there? Okay, and the answer is going to be yes. Why? Because again, you have this and this congruent to each other. So if that piece and that piece are congruent to each other, that means that those two angles are equal. And again, that would make YA your angle bisector. And obviously A lies on YA. So yes, it is the angle bisector. So yes, X and Z are both equidistant from A. So that makes YA the angle bisector, and A lies on YA. And that's all you need to do for that one. So for 4.3, we're going to talk about bisectors and triangles, and we're going to talk about a couple of different types here. But the first definition that we need to know is what concurrent lines are. Concurrent lines are 3 or more lines or rays or line segments that intersect at the same point. So I just drew 3 lines here, and they all intersect right here at this point, which is point G. And when you have the 3 lines that intersect there, again, they're concurrent, but point G is going to be the point of concurrency. That's where they meet. So the point of concurrency is the point where all the lines intersect. Again, concurrent lines can be more than 3, but in triangles, everything that we do is going to be based on 3. Why? Because a triangle has 3 sides. Okay, the first type of point of concurrency that we're going to talk about is something called the circumcenter of the triangle. Okay, and the circumcenter is the point of concurrency of the perpendicular bisectors of the triangle. So basically, if you look at each side independently, and if you were to draw the perpendicular bisector of each side, the point where they intersect is going to be, again, called the circumcenter. So I'm going to highlight. Again, you can see it drawn already, but again, if I just concentrate for a second on just this side that I highlighted in that pinkish color, again, ignore the rest of the triangle. If I drew the perpendicular bisector of that pink line, again, there's your midpoint. Bisect means it has to go halfway, and then perpendicular. So that's that line there. Okay, and if you do the same thing on all your other sides, so if I look at XY, and I ignore everything but what's in green now. Here's the midpoint of green, a line that's perpendicular to that would look like that. And then again, if I highlight in, how about a dark blue? If I highlight this side in dark blue, and again, I ignore everything else but dark blue, there's the midpoint of dark blue. And again, if I were to draw a line perpendicular to that, that is what it would look like. And that is where they all meet. That's your point of concurrency, and that's called your circumcenter. So I'm going to erase what I just drew there just to clear the picture back up. So the only reason that they didn't extend those lines further, again, is just so it doesn't look as messy as what I had just drawn. Okay, so they just kind of truncated them so you could see a little bit more clearly what's going on there. Okay, so the thing that's going to be special about the circumcenter of a triangle is that the circumcenter is always equidistant from the vertices. So if I look back up at that top picture for a second, I know you can see the picture underneath it, but that means the vertices of the triangle. Z is a vertice. If I take Z and connect it to the circumcenter, which is O, X is another vertice. I'm going to take X, I'm going to connect that to O. Y is another vertice. And take that and connect that to O. Those 3 green lines that I just drew are all equidistant. In other words, those 3 green pieces, I should put 4 slashes through it, are all equal to each other. And that's what this bottom picture is. So the circumcenter is always equidistant from the vertices of the triangle. And again, that means that OZ is congruent to OX, which is congruent to OY. So those 3 pieces are going to be equal. Okay. And what's going to happen is the circumcenter of a triangle can either be inside your triangle, on your triangle, or outside your triangle. Okay. And again, 3 ideas of what it would look like. Again, if it's inside the triangle, you have to have an acute triangle. If it's on the triangle, it has to be a right triangle. And if it's an obtuse triangle, it's going to lie outside the triangle. And there's just a little thing here that you can look at to kind of pull it. And there that goes. Okay, so again, this is an acute triangle. All those angles are less than 90. And then if I start to pull my triangle and I have a right triangle, that would be on it. And then an obtuse triangle, notice angle C is getting bigger than 90 degrees and it lies outside the triangle. So just so you can kind of play around and see it a little bit more. On, it's a right triangle. Angle C there would be your right angle. Acute, everything's less than 90, it's inside. And an obtuse, angle C is obtuse, and that lies outside. So the first question is, what are the coordinates of the circumcenter of the triangle with vertices 0, 6, 0, 0, and 4, 0? So the first thing I'm going to do is I'm going to draw those coordinates and connect my dots. And there it is. Okay, so when I look at that triangle, and again, it's asking me what the coordinates of the circumcenter are. So I want to know where that point of concurrency lies. Look at that triangle. Again, the first thing that I want to do is decide, is it an acute triangle? Is it a right triangle? Or is it an obtuse triangle? Okay, and that's a right triangle. Again, this side is perpendicular to that side. So if I scroll up for 1 second, that means if I have a right triangle, that circumcenter needs to lie on the triangle itself. And more specifically, it's going to lie on the opposite side, the side opposite the right angle. So your circumcenter is going to lie on the opposite side. And again, my line isn't perfectly straight there, but approximately where that X is. But I don't want to know approximate. I want to know where it really is. So if it lies on that line, hey, it's going to have to be the midpoint of PRS. It has to be the midpoint of PS. Okay, so really that's what this question is asking me for. What's the midpoint of PS? And we know how to find the midpoint from way back when. We're going to use the midpoint formula, which is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Again, I want to know the midpoint of PS. So x1, y1, x2, y2. All right, so I'm going to have 0 plus 4 divided by 2 and 6 plus 0 divided by 2. Or just 4 divided by 2 and 6 divided by 2. Like 4 divided by 2 is 2 and 6 divided by 2 is 3. So that means that 2, 3 not only is the midpoint of PS, but it would also end up being the point of concurrency. So it would be right there. Okay, and again, it didn't ask you to draw anything else. It just asked you to find that. That's all that you need to do for that question. Okay, so for my next one, if Z is the circumcenter of triangle TVU, find each missing measure. And again, just keep in mind that circumcenter is going to be equidistant from the vertices. So the first thing that you want to do is find TU. Okay, so TU is that entire side. And again, remember, these are the perpendicular bisectors. So that means that this piece is equal to this piece. So if this piece is 19, then TX is also going to be 19. So the entire length of TU would be 19 plus 19, or 38. The next thing that we need to find is YV, and YV is here. Okay, so again, this is the midpoint of that side. So if the entire side is 34, I can take 34 and divide it by 2 to get 17, and that piece will be 17. Next one we need to find is UZ, and UZ is here in purple. And again, that is the vertice of the triangle, and there's the orthocenter. Again, they're all those spots that are equidistant, or those spots that are from the vertice to that center, are all congruent. So that means if this one is 21, that means that this one is also 21. Okay, and then the last one says find the measure of angle ZYU. So let me just erase some of this for a second because we're done with the sides there. So get a little clearer picture of what's going on here. Okay, and we want to know again ZYU. ZYU is this angle right here. And again, that's going to be a right angle. Again, how do I know that? Because if I extend this purple line right here, that purple dotted line, again, is the perpendicular bisector of UV. So if it's perpendicular, that means that that's going to be 90 degrees. Okay, and then the next thing that you have to do is name another segment that equals 21. So again, we knew that this piece was 21, and that means again that that piece is going to be 21 and that piece is going to be 21. So both TZ and ZU would both be 21. Okay, you have another type of point of concurrency, and that's something called an in-center of the triangle. The hardest thing to do is going to be to keep the definition straight, but again, in the time of COVID, you can cheat and look it up. So that's the nice thing. So you won't even have to memorize which one is which. Okay, so the in-center is going to be the point of concurrency of the angle bisectors. So now if I look at every single angle and then I bisect it, and I looked at where those angle bisectors intersected, again, in this picture, G would be the point of intersection. So the angle bisectors CD, AF, and BE are concurrent at G. And again, that G has a special name. It's called the in-center. Okay, the in-center is always equidistant from the sides of the triangle. Okay, in other words, it's GD is going to be congruent to GF, which is going to be congruent to GE. Okay, and in this case, it doesn't matter what your triangle looks like, the in-center of a triangle must always lie inside the triangle, no matter what. So I'll pull in that thing here. There you go. No matter what you do to that triangle, whether it's acute, whether it's a right triangle, again, it's acute here. That's obtuse. Let's see if I can get a right triangle. That's right, like a right triangle if by angle B. No matter what I do, how I move this triangle, flip it around, it doesn't matter. No matter what, that in-center is always inside that triangle. Okay, so if P is the in-center of the triangle JKL, and the measure of angle MJP is 38 degrees, and the measure of angle JKL is 62 degrees, we want to find each missing measure. So the first thing that we want to find is NP, and NP is this piece right here. Okay, well, if I look over here, I know that MP is 8, and again, that in-center is equidistant from the side. So if this piece is 8, that means that NP is also going to be 8. The next thing I need to find is the measure of LJK. Okay, so LJK is this entire triangle, this triangle, sorry, here. Okay, and I think I'm going to need to pull in something from above. So they told me the measure of MJP. MJP is this right here is 38. That's what's going to help me. And now I need to find that entire angle. Again, let me change colors here. This JP is an angle bisector, which means if this is 38, this one is also going to be 38. So the entire angle is going to be 38 times 2, or 38 plus 38, however you want to look at it. And that one's going to be 76 degrees. Okay, let me put this JKL in the picture too. JKL is this entire triangle that I just highlighted, and that's 62 degrees. And the next thing I need to find is JKP. JKP is half of that angle. So if I take 62 and divide it by 2, I'm going to get an answer of 31. Okay, and then the last measure of the angle that I need to find is JLK. JLK. Let me change the color of my pen. I did purple already. How about brown? Okay, JLK is going to be this entire angle there. Okay, if I look at the entire triangle and highlight that entire triangle in brown, okay, the 3 angles of the triangle have to add up to 180. We just found this whole angle back here. We already know this angle, it was given, and now I'm looking for that angle. So if I do X, the angle that I'm looking for, plus the 76 plus 62, that's going to equal 180. Okay, and when you end up solving that, you're going to get an answer of 42. Okay, add 76 plus 62 and then subtract from both sides, and that angle will be 42. Another segment that equals 8 is going to be this last piece over here, which is going to be 8 again, and that would be PO. Okay, we already found NP in the beginning, but you could also say NP. Okay, and our last question, if GE equals 2x minus 7 and GF equals x plus 4, what is the length of GD? So GE is this piece here, and GF is this piece here. And again, if that's the in-center, that means that those two things are congruent, they're equal to each other. So I'm going to have 2x minus 7 equals x plus 4. Subtract x from both sides. I'll have x minus 7 equals 4. Add 7 to both sides. And x is going to equal 11. Hey, again, just be careful. It didn't ask you to find the length, what x is. It asked you to find the length of GD. And again, just also be careful. GD is this piece over here. But again, all 3 of those are going to be congruent. So it doesn't matter what you plug x into. You can plug it into 2x minus 7 or x plus 4, because again, they're going to be the same thing. I'm going to go the easy way, x plus 4. So we just found x was 11. So if I add 11 plus 4, you'll get 15, and that's going to be the length of GD.